So first let's go over the product rule, what's known as the product rule. So it's when we are multiplying two functions together. And it's a little bit different than the sum and difference rule, because in the sum and difference rule you just went ahead and applied the derivative to each separate function, whether they were being added together or subtracted. Here it's a little bit different. You sort of have to work on one function at a time, and it works as so. So if we take a look at the derivative of the function f times the function g, that's equal to the derivative of the first function f times the second function. Now notice it's not a derivative of the second function. It's just we rewrite the second function as is, plus now they change places. Now we leave the first function alone, and we take a derivative of the second function. So the derivative of a product is derivative of the first function times the second, plus the first function times the derivative of the second function. So in each part of the sum, only one function is getting a derivative at a time. Okay? In the quotient rule, we have something, it's a little similar but a little bit more complicated, in fact. But this time, we've got the top or the numerator of our function, our numerator function, and our denominator function. So the derivative of a quotient is the derivative of the numerator times the denominator. Now notice again, just one of them gets a derivative, and this time it's minus the numerator function times the derivative of the denominator, and then that's all over the denominator squared. Now, that seems to be sort of a long, convoluted formula to remember, so there's a little mnemonic device you can use. And in my face-to-face class, I have the students actually chant this. We close the door so we don't disturb any other classes or nobody looks at us like we're weird, but we actually chant the following several times. Bottom d top minus top d bottom over bottom squared. So if you want to chant this along with me to get it stuck in your head so you won't ever forget it, and believe you me, after I came up with this mnemonic device, I was hearing it in my sleep, and at any time I teach it, it's bottom d top minus top d bottom all over bottom squared. Bottom d top minus top d bottom all over bottom squared. Bottom d top minus top d bottom all over bottom squared. Okay? So what we're going to do is we're going to go ahead and apply these two rules and see how they work. Then our first function here is the function f of x equals the product of x cubed minus 3x times 2x squared plus 3x plus 5. Okay. So we clearly have a product here, right? These parentheses butting up against each other tell us that we have a product. So we've got a first function that I'll underline here in blue, and we have a second function that I'll underline here in red. So the derivative of f, that we'll denote with f prime, is going to be the derivative of our first function times our second function plus our first function, we leave it alone, times the derivative of our second function. And I've sort of run out of room here. 2x squared plus 3x plus 5. Okay? So we're going to take it a step at a time. So first thing we do is we just sort of apply the product rule to understand where we're going to apply derivatives. So it's derivative of the first function times the second function, left alone. We don't touch the second function. We just rewrite it as is, plus the first function, we leave it alone, right, because we've already taken a derivative of the first part. So now in the second half, we leave it alone, and then we take the derivative of the second function. Okay? So let's go ahead and figure out what that's going to be. So the derivative of x cubed minus 3x is going to be simple power rule, 3x squared, constant multiple, so we bring the 3 along, and the derivative of x is just 1. I did the derivative of the first function. Remember the second function I don't touch at this step. Now we're going to go ahead and leave the first function alone because I already found its derivative. So in this step we just rewrite it. And then I need the derivative of our second part of our function here. So the derivative of 2x squared is going to be 2, constant multiple rule, times 2x, plus 3 times the derivative of x, which is 1, and then the derivative of 5, which is 0. So our last step is just to clean this up a little bit here. So this will be 3x squared minus 3 times 2x squared plus 3x plus 5 plus x cubed minus 3x times, let's see, 2 times 2x is 4x plus 3. Okay. Now at this point, there's nothing else you need to do with it. This is a fine derivative. Later on, when we might want to set this equal to 0, you might need to do, combine some like terms and so on and so forth. But at this point, since we're not doing anything else with it, this is your fine answer. Okay. So remember, product rule is derivative of the first function times the second function left alone, plus now they reverse. The first function gets left alone, and you take a derivative of the second function. Okay. All right, let's try a quotient rule. So let's try our function g of x equals 3x minus 2 all over 2x minus 3. So now, again, we've got a numerator, or our top function. We've got a denominator, or our bottom function. There we go. So let's recall that the derivative of a quotient is, let's chant it out, bottom d top minus top d bottom over bottom squared. Okay? So that means our derivative is going to be, okay, let's do the easy part, bottom squared, right? 2x minus 3 squared. That's the easy part, so we can do that. Okay? And it's bottom d top. So it's bottom d top. We don't do anything with the bottom, since it's just bottom. We rewrite it. Times the derivative of the top minus, I have to extend my fraction bar there. Now they reverse. Minus top d bottom. So the top just gets rewritten as is. And we take the derivative of the bottom. Bottom d top minus top d bottom over bottom squared. So let's go ahead and find our derivatives here. 2x minus 3. The derivative of 3x minus 2 is going to be 3 times the derivative of x, which is 1, so that's just a 3, minus 3x minus 2 times the derivative of 2x minus 3, so that's 2 times the derivative of x. Derivative of x is 1, so that's 2 times 1, or just 2. All over 2x minus 3 squared, all over bottom squared. Okay, and then of course last step, this I'm going to clean up because this is easy to do. This is just some multiplication. So I get 6x minus 9 minus, now be careful here because I want to make sure I subtract off the entire quantity that's in this second part of the numerator. 3x times 2 is 6x, and 2 times 2 is 4. 2x minus 3 squared. And last but not least, notice we get 6x minus 6x, so those cancel to give us a 0. And then we got negative 9 minus a negative 4. So that's negative 9 plus 4, negative 5 over 2x minus 3 quantity squared. Okay? So remember, quotient rule is bottom d top minus top d bottom all over bottom squared. Now, we aren't always going to have where we just apply the quotient rule or just apply the product rule. You might, in fact, end up with cases where you have to apply both. So our next example gives us an example of how that works. All right, so I've got a new function here. F of x equals the product of x plus 5 over x minus 1 times 2x plus 1. And the idea here is we want to find the slope of the tangent line to this graph at the point 0, negative 5. Okay? Now, you might ask yourself, well, what rule am I going to need to apply first? Okay? Well, always think of working from the outside in. work from the outside in when applying your rules. And we'll see this come into play a little bit later when we do something called the chain rule, and we have the generalized power rule, and we'll have some function raised to a power, not just x to a power. But you'll notice you'll keep hearing me say in, outside, in, outside, in. So we want to work from the outside in. So the outermost operation that's going on here is not division or the quotient, it's actually the multiplication, right? That's outside of the division. So the outside part is the product rule here first, okay? So f prime is we're going to apply a product rule, which says product rule is derivative of the first function times the second plus, now the first function is left alone. Oh, sorry, I wanted that in blue. Times the derivative of the second, right? They switch roles in the second half. Okay, so that's the product rule that I applied here, right? Product rule. Okay. Now within that, when I take the derivative of the first part, I'm going to end up with a quotient rule now. So the derivative of x plus 5 over x minus 1. Well, that's bottom d top, bottom, x minus 1, times the derivative of the top. It's the derivative of x plus 5. That would be the derivative of x, which is 1. It's the derivative of 5, which is 0, so that's just 1. Minus, okay, so it's bottom d top minus top, x plus 5 times the derivative of the bottom. Derivative of x is 1, minus the derivative of 1, which is 0, so we get just a 1, all over bottom squared. All right, so we got that part, and then we're going to multiply that by 2x plus 1 plus, working our way across here, x plus 5 over x minus 1 times the derivative of 2x plus 1. So that would be 2 times the derivative of x, which is 1, plus 0. So we get just a 2 there. So let's clean this up. We get an x minus 1 minus an x plus 5. So let's see, the x's will cancel because we got an x minus an x. And then we've got a negative 1 minus 5, so it's negative 6 over x minus 1 squared. But we've also got times the 2x plus 1, so I'll just slide that up into the numerator there. And then plus, I've got an x plus 5 over an x minus 1, and then times it 2. So I'll just go ahead and slide that in the front there. So 2x plus 5 over x minus 1. Okay. Now that's the derivative of that particular function. It's a little long, but it's certainly a lot easier than if I had to do the difference quotient and taken the limit and all that nonsense. That would have taken me forever to do. Remember, a derivative is the slope of the tangent line or the slope of the curve at any point, but we want it specifically at 0, negative 5. So f prime at 0 is negative 6 times 2 times 0 is 0 plus 1, or 1. 0 minus 1 is negative 1, but when I square that becomes positive 1, plus 2 times 0 plus 5 is 5, all over 0 minus 1 is negative 1. So this is negative 6 minus 10, or negative 16 would be our slope of our tangent line.